Okay, I'm going to do a basic, straightforward problem. So let's say I have this circuit, and I've got an AC source, 8 angle negative 20 degrees volts. I've got a capacitor minus J3 omega. Got a resistor, it's 4 ohms, and I have an inductor, J5 omega, J5 ohms. And I want to find the complex power absorbed by each element. And I'm going to find the complex power, but I may also find the reactive power. I may also find the real average power. We'll see. Okay, so first of all, notice that our 3 branches are in parallel. So we have the same voltages across all the branches. So I will call this I1, and I will call this I2. So this is ground. So I1 equals 8 angle negative 20 over minus J3 plus 4 equals 8 angle negative 20 over 4 minus J3 equals, I'll change that to polar, 1.6 angle 16.87. I2 equals 8 angle negative 20 over J5. And that gets me 1.6 angle negative 110 degrees. Alright, so now if I wanted to find I equals I1 plus I2. Remember, it's not easy to just add them in polar form the way they are. So I will just take that plus that, and I'll leave it, do I leave it rectangular? No, I'll change it to polar. So 1.43 angle negative 46.57. Alright, so now to get the complex power for the source, so the complex power will be 1/2 V which will be 1/2 8 angle -20 times 1.432 angle positive 46.57 degrees. Let's see what I did wrong. So 0.5 times 8 angle -20 times 1.432 angle 46.57 5.12 plus 2.56 plus J 2.56 VA, that's for our complex power. Now if we wanted the real average power, that would be 5.12 watts, and the reactive power is 2.56 VAR. Now if we just want the capacitor, probably easiest to use the formula 1/2 magnitude of I1 squared and then the impedance of the capacitor, which is 1/2. Now the magnitude of the current is just 1.6, so 1.6 squared times the impedance of the capacitor is minus J3. And if you multiply that out, you get minus J3.84 VA. Now it's VA because we're calling it the complex power, but it is, of course, all reactive. Now for the resistor, we expect to get all real. So 1/2 times I1 squared times ZR is 1/2 times 1.6 squared times 4, which is 512 VA. And then for the inductor, it's 1/2 I2 squared times Z for the inductor. So that's 1/2 times 1.6 squared times J5, and that gives us J6.4 VA.